So in the early days of LLMs, not long ago, right? Probably 2 years ago, right? The LLMs started with support, text support, right? Text. They take in text input and then they generate text input, text output, right? Fast forward today, lots of advancements and evolution happen, and now you can deal, or the LLMs have evolved to take different formats like image, audio, video as the input, and can even generate them. And also, while bridging the language barriers, it can support in multiple languages. And today we have two speakers. Let me introduce myself. I'm Maruti, a partner architect here at Google. And as part of my role, I closely work with our database partners like Elastic to make sure how easily they can build their solutions and products on Google Cloud, and how easily they can integrate with various Google Cloud services, including data and AI, to help you, build your data and AI foundation on either Google Cloud or Elastic. And with that, I want to joining me is Abhishek. Abhishek, over to you for quick intro.
Hi, I'm Abhishek. You can call me Abhi. I'm a machine learning engineer, part of the applied AI engineering team at Google Cloud. So work on some of your AI products that you may have used as part of Vertex or Cloud AI. Yeah.
He's on the most happening team at Google. So it's like one of the major challenges I face personally, and I hear from people, is how to keep up with everything that is happening in this space, right? And that is where both Google and Elastic try to build solutions that can help you focus on your applications, your use cases, and we take care of making sure the latest advancements and latest technologies are baked into our platforms. Now, you can deploy or use Elastic in various options or various platforms, but let's spend a few minutes to talk about why Elastic on Google Cloud makes sense or is the best combination. Before that, let me quickly talk about our AI platform. I've seen some faces in previous events and conferences, but I just want to understand how many of you seen this, the stack of the AI platform. Cool. So thank you. So Google has this AI platform called Vertex AI. Again, that's not a new platform. It existed for a while, maybe different names. But in the past days, we supported predictive AI use cases. But now with the evolution of this AI, the models, the tools and use cases, we evolved this platform to help you build predictive and generative AI use cases. So one platform to help with your various AI needs, whether it's predictive or generative AI. And starting with the infrastructure, Google has support for both GPUs and TPUs. That way, for your applications, if you're using GKE or compute, you have support for this robust infrastructure to build your use cases. And then Google has proprietary models called Gemini. Gemini is the state-of-the-art models from Google. And when you're on the platform, you can use Gemini models. But in addition to that, we learned that our customers want to use different kind of models from different vendors, like partner models like Anthropic, Mistral. We have support, or you can use them seamlessly or easily in the Vertex AI platform. In addition to that, we also have support for you to take advantage of open models like Gemma from Google, Llama, and a few other open models. So we have like 160 plus models that are available on the platform. That way, we're on the Vertex AI platform, not just the Gemini models. You can use various partner and open models or combination of all these to power your application. And on top of that, these models are pre-trained, right? They are kind of pre-trained on a specific data set, and there's a cutoff date. But now you wanted to apply these models or take how these models work to your enterprise data or your application, right? In addition to that, you may want to fine-tune these models to fit your domain-specific use cases. And that is where we have Model Builder, which can help you tune your model or distill your model, or even build a CI/CD, or in the context of AI, you have ML ops if you're dealing with machine learning CI/CD use cases, or if you're thinking about generative AI, it's generative LLM ops or generative AI ops, right? So Google provides this platform to help you with model customization and also build your pipelines or CID, cover your continuous integration and continuous delivery kind of integrations. And on top of that, agents are making big wave in this AI industry these days. I know the previous catch-up is all talked about AI agents, right? So irrespective of your use case, if you want to build agents, agent builder platform can help you build agents in a, depending on your use case, you can either use the no-code platform that is available, or you can take advantage of open source frameworks like, let's say, LangGraph or LangChain, and you can deploy them on Google Cloud. In addition to that, if you're a Google Workspace user, like if you're using Google Docs or any of the Google Gmail, etc., kind of applications, Gemini is integrated into that. So we use Gemini to power our own products as well, so that you get AI experience when you're using Workspace and Google different Google Cloud products as well. And on top of that, we also have various AI solutions which are catered towards are designed to help with certain industry use cases like healthcare, contact center, retail, etc. Now, let's talk about where does Elastic sit. Now, if you zoom out a little bit, this is our data and AI foundation platform that can help you build your AI use cases, right? And now, if you see here, we also work with our third party or partners like Elastic. So, as part of this foundation platform, you not just Google Cloud first party products, you have also access to third party products like Elastic to meet your use cases. And again, this is another representation of the previous slide. But again, this talks about the specific components which fit in the different life cycle stages of you building your AI application. And Elastic is not just available on Google Cloud, but it's also integrated with various products like BigQuery. So if you have data which is sitting in your data warehouse like BigQuery, and if you want to take advantage of Elastic sophisticated search algorithms or such solutions, you can easily move the data sets using data flow like Apache Beam pipelines to Elastic with low code or no code, and you can take advantage of Elastic, the such use cases, such solutions. Now, how can you get to deploying Elastic on Google Cloud? So Elastic is available on Google Cloud Marketplace. Someone asked me what exactly is Marketplace during the networking event. So if you're not familiar with Marketplace, Marketplace is a place or a portal where you can browse and purchase various third-party ISVs, different products on the Google Cloud platform. So that is, we call them as technology partners. So Elastic is on Marketplace. So as a customer, you can actually burn down your commit. If you're a Google Cloud customer, and if you want to use whatever you committed to Google Cloud, you can burn down or use those credits to purchase Elastic. And also, you get one bill. You don't need to deal with two companies or two different vendors to deal with your purchase orders or billing. It's like one unified experience when it comes to purchasing different products from Google Cloud. And like I said, my team especially works with Elastic and different product teams within Google Cloud to see how we can make sure, innovate, and also integrate. That way, Elastic is deeply integrated or blended into the broader Google Cloud portfolio. And again, if you're a Google Cloud customer, I don't know how many of you are Google Cloud customers, but there are some incentive programs that you can take leverage, or if you want to learn more about that, just chat with us offline, and we can help you connected with the right folks. Now, we have a demo that I want to show you in a few minutes, but I want to talk about this particular architecture, the integration we have, which is basically, as an enterprise, you might be using Elastic to power your such experiences or use cases on top of your sensitive databases or different kind of data that is sitting at various databases or documents, etc. Now, by taking advantage of Vertex AI platform and the LLM Gemini especially, you can build conversational such experiences on top of your private data. Now, here is the architecture. And imagine there is a website like Home Depot, for example. I think one of the person from Milan built it, so he made it as Homecraft. But think of this as a Home Depot. Now you have different products that are available for you to purchase to work on your DIY project or a project with a contractor involved. Now you go to the website, and then what materials do I need to build an irrigation system? And the way it works is that data is available on the Elasticsearch. Again, Elastic Search Relevance Engine. If you're not familiar, Elastic came up with this a advanced vector search kind of offering, which has pre-built data integrations. It has various ways to create embeddings on top of the data that is sitting in Elastic, and also easily integrate with your Active Directory or LDAP, and then different models, large language models like Gemini. So the flow is when the user enters the question, like a prompt or query, that request is sent to the Elastic Relevance Engine. But before that, the query or the prompt is converted into embedding, and the similarity search or vector search is done. And then also the RBAC plays a huge role here, because the data that the user has access is only returned back. And with that particular similarity search data that was retrieved, like a document or set of information that is relevant to the question, is sent back to the Gemini LLM. That is, I'm sure you guys know something called RAG. So that is what is happening here. And once the Gemini takes the question and the additional context, augmented context, it generates a response, and the final response is sent back to the user. How many of you built RAG system in production? One. Okay. How many did a POC? Probably, a lot of people. Good. Yeah. That's why, like, I don't know, like 6 months ago, every talk started with RAG. I think now we have to move ahead. I think plus.
Who knows what RAG is, by the way?
We got money to pay for RAG.
Agentic.
Yeah, and now it's agentic. Or do we need to explain RAG for anybody, not that anybody's left behind?
I think the architecture, what you saw, it's what is happening, retrieving the data that is relevant. Sorry?
You told it out.
You mean for authentication or authorization? I mean, for some data, it might come in somewhere.
No, this is
It's not a hard requirement.
yeah.
Enterprise.
No, this is the
You go right out.
this is the architecture of the demo that we built. So so let me quickly show you the demo. Okay, so here is the user interface for this Homecraft home improvement. So 1 minute. I'm sorry. So I'm gonna ask this question, simple question. Sorry, I'm trying to.
It's even in French.
Yes.
For the advanced.
I'm going to ask you to translate for us. So this is a simple question, like I need a bathroom light. Can you list some of the product catalog from a IP44 certification and above? Whether I'm doing it live, so let's see. I hope it works fine. Takes a while. Again, just because of the demo, we use like the basic infra or the basic tier kind of things, but in production, you should see this very fast. So you can see it give you bathroom lights with IPv4 certification. And like I showed in the previous diagram, we had the data coming from different data sources. Like some of the order information is BigQuery. So we use data flow templates to move the data from BigQuery to Elastic. Batch, we did it upfront. And then some data is coming from web crawling. We did web crawling on IKEA and some web Home Depot, and we store that information as well. So it's coming from different data sources.
French.
Yeah, I'm gonna ask that. I don't know why my lab's not working. So now let's see French. Let's say I also have this translation I posted here to make sure maybe you can confirm if it's right or not.
My French is not that great, but
Okay, perfect. So let's ask that question as a French user who visited, United States maybe, or wants to visit, wants to know how this. Yep. Don't ask me to read that, but yes, I validated it. It actually gives you the right information.
Why it's in Europe?
Cool. So there's a last, step. Let's try. Okay, no, this is the big. I mean, because I said the data from order information is BigQuery. I just want to show you that even if the data is sitting in BigQuery, we have native integrations that can help you get this order data. Yeah, maybe the system instruction is set now to only understand French. I don't know, just kidding. Yeah. So, okay, so here is the past order data, pre-baked data, but again, from BigQuery to Elastic, the data flow templates support both batch and streaming as well. So the advantage of data flow or Apache Beam offering that we have on Google Cloud is you can have the same job which can do both batch and streaming from BigQuery to Elasticsearch. The last one, I want to show the multimodal aspect of this model. So I'm gonna use this image. So here is the image. Just showing a paint box. So I'm gonna upload that. Yeah, here you go. This one. And then I give the prompt. What's this image? Do you have similar products in your catalog? If yes, list them with price and details. Okay, so the first one is Vision, which uses the Vision API, and it said that's a paint box, and then it sent a request to the Elastic, and it gave you, all the information, and then the price details, etc.
But some of it is still French now.
I think that the catalog data we have, it's in
Okay.
Yeah, we have the French mixed.
That's a paint.
Even this one, if you see, I think, yeah, no, it's the Valerio. We should ask Valerio. So, okay. Yeah. Okay. Perfect. Cool. Now let me step back. So this is what we saw in the demo. The code for that is on the GitHub. We can share with you. If there's an Elastic free trial as well. So if you guys want to just implement that, you can give it a shot offline. But this is what happened in the background. But at the same time, now stepping back and think about in general when you're building your RAG applications to bring your enterprise knowledge to LLMs, here are like typical steps that are involved in both preparation and runtime phase. Again, you have to do lots of steps like connecting your data, like we talked about from BigQuery to Elastic and web crawling, different, as enterprise, your data is sitting in different systems. Right? So now parsing, understanding doc AI, or if you have like images in a document, you have to do a layout parser. I think Abhishek is going to talk more about those things. And then chunking. Chunking is the strategy you need to build on top of your data. That way, for storing and retrievaling, it's more easy instead of retrieving the big documents or the entire chunk of documents. And then embedding, obviously, in order to do vector search or similarity search, you need to convert the actual text data or image data to embedding, text or any kind of multimodal embeddings, and then store, right? And as part of runtime, then as a user sends the question, you need to understand that, do the pull up the relevant embeddings and then re-ranking them, which are more relevant for that particular scenario, and then send it to the Gemini, and then end of the day you have to host this APIs and also scale in demand, and also build some evaluation systems around your applications as well. So you need to do all of this if you need to do by yourself, right? And also on top of that, responsible AI is making waves. I'm sure you've been hearing this a lot, right? So it's not just working on like just the foundation models. In a typical scenario, you will be focusing on a bunch of things like model customization, right? So like we discussed in a end-to-end life cycle of your application, you need to focus on how do you monitor your applications, how do you deploy, and how do you evaluate. So you have to do all of that. On top of that, you have to take care of your responsibility as well in terms of if the request and response are not harmful and are adhering to certain standards. So Google has all this tooling built into the platform that way, both Elastic, by taking advantage of Elastic and Google Cloud, you can just focus on your use case and then take advantage of the tools and build your end-to-end generative AI use cases and applications. Again, we saw how the application we built scanned the image and gave you the relevant things. But again, you can actually build any kind of vision search kind of use cases with Gemini. And here is an example. You can take a picture. I mean, I do that all the time right now. Even the Gemini assistant, we just parked our car there, and there are like multiple yellow signs. I don't know. I can't understand. I couldn't understand. Can I park here or not? So I took a picture and asked, can I park here or not? He said, no, don't park here. So, so I think the creativity or the use cases are endless. And we're constantly trying to see how we can work together to make this experience seamless and easy for you guys. If you have any use case or if you want to chat more about things that you're doing with both Elastic and Google Cloud, let us know. And with that, I'll hand over to Mr. Abhishek, who's gonna talk about some of the latest advancements that are happening in the LLMs and Gemini space.
Thanks, Maruti. Awesome. So let's probably deep dive into a couple of things that Maruti spoke about, right? So I'm sure you would have all heard about embeddings and the different embeddings that are available, right? So just wanted to give you a brief update on what we are doing on the Gemini/Vertex side of things. So we actually have various embedding models, as you can see, like the different versions. Text embedding 004 is our latest English-only model, right? But we also support multilingual embedding. So in case your application needs to support various different languages, we support more than 120 languages, and we can actually capture the semantic relevance from your embedding with almost 120 languages, right? And again, the input dimensions are about 3072 tokens, and then your output is about 768 tokens. And you can try it out at about 600 requests per minute on Vertex AI. And I think it's almost pretty similar on AI Studio as well, where you can also try it out for free. Yeah, sorry, go ahead.
What do you mean by input dimension? Because it looks like the output dimension is the dimension of the embedding itself.
Correct.
The input is supposed to be in either text modality or image modality. But
Correct.
so what's the dimension for the input?
So it's tokens, number of tokens,
Oh, I see.
essentially. Yeah. Yeah. So yeah, the output is dimensions while the input is tokens. Yeah. Same for multimodality as well, right? So we in fact offer a multimodal API that can take in inputs of text and image pairs, as well as videos as well, right? So if you want to build like a reverse video search or such use cases, you can do that. In fact, the cool thing is, if you notice that we can actually modify the dimensions for these embedding models as well. So right from 128 dimensions to 1408, you can set whatever dimensions you want and you can save on cost. But then all the inputs that are passed through the multimodal embedding API are built in the same vector space. So what that means is, let's say you have an image and a text that you're kind of passing through the same model, right? In fact, the dimensions are the same. So you can theoretically do a text to image search or image to text search, text to video, video to text, video to image, image to video search as well. So any to any sort of multimodality and retrieval is possible when you use the multimodal API itself, right? So how do you kind of get started with using it? It's fairly simple, just a couple of lines where you can just specify what is the model name, the endpoint name that we just spoke about, and then you pass in whatever text field or image or whatever field, right? But there's another cool thing that we built recently that we call as task type. It's kind of like an adapter that is used to enhance the accuracy, specifically based on whatever task you're doing, right? Because with embeddings, you can do a bunch of different tasks. Obviously, search being the most famous one, but you can also do like just simple semantic similarity. You can cluster different embeddings based on their nearness and stuff like that. In fact, we also have a new task type that is called code retrieval. So in case you're building like code-based applications where you want to do RAG over code, you can actually use code retrieval as a task type as well, right? So task type greatly enhances the accuracy of your embeddings depending on what task you're trying to do. So again, Maruti discussed this, but just to double click sort of on this. So let's say you have any sort of modality of text or image, you can basically convert them into embeddings, and then you can store your entire corpus in your favorite vector store like Elastic. And then basically you have a user that's running a query, and then you run it through the embedding API in real time, and then you do a semantic similarity or any sort of a vector comparison. And then based on that, you find the nearest neighbors, you rank them, re-rank them, and then show the top K or how many of the results that you want to do, right? And this works even for videos, by the way. So you can actually pass in videos, get the same embeddings, and then this pipeline can technically, scale even for video-based use cases. So in case you're planning to do some cool, video-based retrieval systems, it's pretty nice for such use cases as well.
And you take 4-second intervals?
Sorry?
You take 4-second intervals there?
Yeah, I mean, it depends on how you want to do it. So in this case, you can theoretically fit up to 1408 dimensions for videos. So it depends on like what size of the video it is, what quality of the video. So it depends. I guess in this case, we just chose 4-second intervals where we chunk the video and then we pass that.
So a good question. You said that the maximum number of token for our videos is 1408.
Yeah.
So how long of how long of the duration is that number of token corresponding to?
Again, it depends on the quality of the video, the bit rate of the video, and stuff like that. So it can greatly differ on 4K videos to, let's say, 720 pixel videos, right? So maybe in 720 pixel videos, it could be about 10, 20 seconds. On a 4K video, it could be like 2 seconds. So it depends on a bunch of different factors.
By second, do you mean like, number of frames or?
No, it's actually, yeah, number of frames. But it depends on, again, your video, if it's shot in 60 FPS, 30 FPS. Yeah. So a good way to estimate that is we have a token estimation API where you just upload whatever file it is that you want to count the tokens for, and it'll give you the number of tokens. So fairly straightforward, and then you can divide it. Yeah. Yeah, so that's a quick sort of overview of that, right? But even with documents, this kind of is very important, right? And Maruti again spoke about like chunking and parsing. So at Google, we actually have a production scale document service that we call as Document AI. And in fact, we have a bunch of different pre-trained models depending on what kind of, document you're using, like for example, tax forms, ID cards, a bunch of different enterprise models, right? But recently we launched this new model called as a layout parser. So what it does is on all sorts of complex layouts, like, merge cells within tables, merge rows, stuff like that, or scientific figures, or even like multimodal, images embedded within PDFs and stuff like that. We actually launched a new model called layout parser. So as the name suggests, what it does is it extracts the layout and then does the chunking, right? So if we were to take an example, let's assume this is the document. It first gets the layout of the document, like it identifies what are the hierarchical headings, subheadings, paragraphs, lists, points, all those kind of structure, whatever logical structure is in whatever document. And then based on that, it does a classification and understands that within a subheading, all the sections are related to each other. Within a heading, all the subheadings are related to each other. Within a list, all the different points are related to each other, right? And then it clusters them and then crafts a chunk. And then based on that, you get a markdown rendered layout of that particular chunk itself. So you can essentially see, like, you don't really need to specify how the different chunks are related to each other. Maybe if you've built RAG applications before, you would see things like chunk overlap, chunk size, and stuff like that. You don't really need to specify this here. because the model automatically takes care of how the different sections are related to each other and, groups them and then chunks them together. Yeah, sorry.
So how does the detection model work under the hood? Is it like a supervised CV model?
Uh, We use a bunch of different OCR plus LLM services. So it's not just one model ideally. So you have a bunch of different models working on different sections. Yeah. Any questions? Feel free to interrupt me anytime, by the way. Yeah. Awesome. So once you have that, you can basically, put it in your favorite vector store again, and then build your RAG applications. So speaking of embeddings, again, we recently launched some updates to our embeddings. As I mentioned, code retrieval is one of our task type, which greatly enhance the accuracy. We also have dynamic dimensions, so you can choose to make your embeddings as small as you want, but also keep as much performance as possible, so you don't lose out on the performance and save costs by reducing the dimensions. And my favorite part, which is the last part, is tuning your embedding specific to your data, right? And this is very interesting, especially when you want to build a high quality search product itself. So let's talk about this tuning itself, right? And what exactly happens underneath when you talk about customizing or tuning an embedding. So at Google, we recently, well, not recently, about 6-7 months ago, we launched this feature within Vertex AI, but it's based on this paper called as a search adapter from Google Cloud AI Research. So you might be familiar with the left side of the diagram, which is basically you have your text queries and your corpus, and then you have an LLM encoder, which basically does the embedding of the particular query and the corpus. And then you have some sort of a similarity function that calculates how close they are, and then you sort them based on ranking and stuff. And then you finally have your corpus that you can plug into an LLM and do RAG or whatever it is that you want to do, right? But then what do we do with customized embeddings is essentially we take each text query and then we take each part of the corpus and then we build out the query corpus pairs. And then based on that, we train a custom LLM encoder, which extracts the embeddings from your corpus and from your query. And then based on the query corpus pairs, we then, train a custom adapter layer on top. And it's a pretty small layer, but it gives you a lot of, performance boost because you're specifically training it on that query corpus pairs based on the positive or negative relevancy scores itself, right? And then finally, you do your similarity search as usual because the adapter gives you your latest customized embeddings, and then you're able to do this, right? I know it sounds complex, but it's pretty easy to use when you want to use it. The way you do it is you prepare a query set, which is a list of all your queries. You prepare a corpus set, which basically says all the pieces of chunks or text that you want to have. And then you write a correlation set, right, which says that my query 0 is related to chunk 0, and it's a positive score, which is 1, or you can give it a negative score of -1, or you can give whatever score weighting that you want to give, right? And again, the negative part is optional, but definitely do give the positive part. And once you build this kind of a correlation between these query and corpus, you basically upload this to a cloud storage bucket. And then there's a model tuning job, which kicks off a training pipeline. And it's built on Kubeflow. You can take a look at how it works. But then it kickstart that pipeline. It ingests the document and then runs the training and gives you an adapter layer. And then that adapter endpoint is deployed on Vertex AI. And then you can just call it similar to how you do the standard embedding models on Vertex AI, except that you can name it whatever, a unique name. I guess in my case, it'll be text embedding Abhishek or something like that, right? So you can name it whatever you want and query it. So just to kind of go through a bit more in detail on how this happens is, again, you have your query and your corpus, and then there's a custom encoder that we already have as of today. And then you build an adapter layer on top, and then you basically train that adapter layer, and then based on that query corpus pairs, right? And in order to ensure that we don't overfit on that particular query corpus pairs, we use a specialized regularization function and a specialized normalization functions, and then we build the overall adapter layer itself, right? And based on this adapter layer, during serving time, we just put this adapter layer on top of the already pre-trained model that we have, and then you get a new embedding that is more related to your particular data set itself, right? So this is a very cool, but it leads to extremely significant performance gains. On Gemini-based embeddings, we have seen up to 10% improvement in terms of accuracy when you use custom embeddings with tuning, and again on GPT models and other different models. You can take a look at the paper. It gives you more details in terms of how much of a performance boost you get with embedding tuning itself, right?
So is this adapter a lower adapter or something similar?
It's kind of like a LoRa adapter where you build an adapter layer, but we have a specialized regularization function that we built as well. Yeah. And yeah, it's pretty small. It's less than 1 million parameters overall. Yeah.
So is performance the only incentive to go for customizing the embeddings?
I mean, obviously also domain relevance and stuff like that, right? So yeah. But yeah, performance definitely improves quite a bit, especially when you have a custom data set that, let's say if you're building for fintech, right? And most LLMs will not have like very detailed knowledge on your data set or healthcare or any such specialized domains where LLMs can't really get the data from like the general internet. Yeah, sorry.
So optimize on all 768 dimensions.
Sorry?
Like optimize on every single dimension in 768.
Yeah, it basically builds an adapter layer on top of it. It's a custom separate adapter layer on top of it. But it's that adapter layer is trained specifically on this corpus that you just built here, right? So based on that corpus relevancy, that's how that adapter layer is built. And the obvious question then becomes, let's say I have 100 pairs, right? Then the model will obviously perform better on those 100 questions only. And if you ask it something it doesn't know, it will definitely be wrong. But because of this unique regularizer that we built, we can basically prevent overfitting of the model and ensure that it actually learns from the corpus.
Wrong answers.
Sorry?
Does it give you wrong answers?
Well, it depends again on how complex your data set gets. But yeah, we can have a chat in detail to understand a bit more on that. Awesome. So from the survey that Maruti did earlier, we understood that most of you have not taken a, let's say, a RAG or a search application to production, right? So wanted to understand, like, is evaluation one of your key concerns, right? When you're actually taking such an application to production. So how many of you think evaluation has been a barrier? Okay, one. A couple, okay. Yeah. Yeah, so at least in my opinion, evaluation is one of the key barriers, I feel, because again, there's so many moving parts that any part of the application or pipeline can go wrong. So with Vertex AI, we actually built this generative AI evaluation service, right? And what exactly it is you can basically evaluate any model. It can be Google's foundational models like Gemini, or open source models like Llama, Mistral, whatever it is, right? Proprietary foundation models like Anthropic's Claude, or customized models, which are models that you fine-tune either from Gemini or Llama or whatever it is, right? So any model, essentially. Along with that, we give you two different evaluation modes. So one is an interactive online service where you can test it out on a few or some simple amount of queries, or an asynchronous one if you want to set this up in production where you want to monitor and evaluate your pipelines in real time. And then the various evaluation services that we provide and kind of what you should have is a computation-based evaluation, an autorator-based evaluation, and a human evaluation, right? So what exactly are these? So when we talk about computation, it obviously means you need to have two parts to evaluate, right? One is obviously your LLM generated answer or RAG pipeline retrieved context or whatever it is. On the other hand is your ground truth. So for any kind of computation metric, you need to have the ground truth. And in that case, you can do a bunch of different metrics like lexicon-based, like Rujal sum, count-based, such as accuracy, NDGC, recall at K, or embedding-based, where you can calculate semantic similarity as well, right? The other one is called as an autorator, where you use LLM as a judge, where you don't need to have a ground truth, and you can basically bring in your answers and use an LLM to score it. The other one is something that we use at Google a lot, which is called as auto side-by-side, where you get the outputs from two different models and use a third LLM model to vote on which model's answer is better. This is where you want to probably capture a bunch of semantic understanding. And then with autorators, the key thing to get is not just the scores, but also the explanation of why the LLM scored it in such a way that it did. And again, as mentioned, you don't need ground truth for this, right? Which is kind of very key because in most cases, we start out with absolutely no ground truth. And finally, again, the best evaluation is by humans, where you can have humans come and evaluate. Yeah, we're becoming extinct. Yeah. All right, so let's take a quick look at how to actually do this. So this just three simple. Oh, sorry. Yeah, go ahead.
Well, the problem, people always try to sell you evaluation tools.
Yeah.
They give you a number, but a number didn't tie to any particular meaning.
Exactly.
Because even it's 100% correct, it will give you 92%. But what's wrong with the last 8%?
Exactly.
It's wrong at 32%, but why 32% correct?
Correct. I agree.
All the number is just a number.
Exactly.
It also depends on the questions, how statistically dominant LLM.
Correct.
This scale versus that corner case is not the same relevancy.
That's exactly.
So we
true.
always get numbers. What does it mean?
Yeah. No, I agree. In fact, that's why we don't give a numbers based, at least like in a scale of 100, we don't do that. In fact, we kind of want you to make as many metrics as possible, but keep the scoring scale from 1 to 3 or 1 to 5, where each value has a semantic meaning, right? And I'll talk a bit more on that, but we have a bunch of out-of-the-box metrics that you can use or build your own metrics as well. But ideally, you should never have a scoring out of 100 because what would be the difference between 31% and 32%, right? It's like statistically impossible to predict
That's
that.
what people report tell you this is better LLM right now. I put one more digit, better digit.
Well, on academic benchmarks, it makes sense. But on, on your own benchmarks, it doesn't make sense for sure. Yeah. So let's take a look at what we call as a rapid evaluation or a vertex evaluation service, right? So there's essentially 3 steps. You prepare your evaluation data set, create an evaluation task, and run the task, right? So very simple. Let's say I want to evaluate a RAG application. So I have my instructions, which are my prompt templates, ideally. And then I have my contexts, which are the contexts that have been retrieved from my vector database. And then I have my final answer from the LLM itself, right? And then again, I can have many different lines of this, however long I want. And then in the evaluation data set, it basically builds a combination of each one of this, right? Once I do that, I basically put them all in a data frame, and then I can define some of the out-of-the-box metrics. So in this case, I'm evaluating a summarization task. So some of the metrics that we provide are like summarization quality, groundedness, helpfulness, verbosity, stuff like that. But then again, these are just open source prompt templates that you can go take a look at how we have built the scoring for. And then once you do that, you just do task.evaluate and pass the prompt, and then it'll basically go run it, right? And this is how the UI looks like. Basically, you can expose this in Vertex experiments. You can see the standard metrics like blue, coherence, and the different fluency metrics that we just got. And then you can actually double click and take a look at specifically, not just the score, the confidence at which it is scoring that. Along with the confidence, it also gives you an explanation of why it gave you that score. So let's say it scored a 5 on 5. Let's assume it's out of 5. it'll give you a confidence score and say, I'm only 80% or 0.8 confident that this is, 5 on 5. It may be 20% unsure, right? So it gives you that score so that you can account for the statistical difference. And then basically also gives you an explanation that you can combine with human feedback and then later on choose to tune your model using RLHF or any kind of different tuning techniques, right? And again, obviously you can visualize it as well. So this is the cool part, in my opinion, where you can write your own custom metric. So let's say you work in an industry where none of the metrics that we provide out of the box make sense. No worries, you can just go write your own metric as to what that metric is, what are the different scoring scales from 0 to 5, and give a detailed explanation of what does 1 mean, what does 2 mean, what does 3 mean. And then basically you register that metric, and then you can run this metric within this, right? Yeah. Maruti security updates. Yeah, we do provide some metric bundles as well. Like, for example, if you do a lot of function calling or agentic behavior within your applications, we have like metrics like, is the tool call valid? Does the tool name match? Does the parameters within the tool call match? Again, a bunch of different metric bundles that you can add on, right? Yeah, so definitely, in my opinion, evaluation is certainly key for you to build a RAG application or a search application. And then it gives you that confidence to take it to production. And not just once you're in production, you can actually keep up the evaluation to collect all sorts of data and then tune your models, tune the parts of your pipeline that doesn't work well, and yeah, go ahead.
Question.
Yeah, that's right.
In this metrics, do you capture non-functional metrics like performance, latency, failure rates and those sort of things?
Yeah, those we capture in general GCP monitoring. We have Vertex AI monitoring that basically captures all the endpoints APIs called, how many failed, how many passed, what is the average latency, P99, P90, P50, all those stuff. Those kind of things.
But for different models, if you want to do a comparison, how are they stacking up with each other?
Yeah, I would then recommend to write your own sort of a tracing, right? We do provide a lot of, trace applications. So we integrated with OpenTelemetry, which is the standard at the moment. So you can just add that tracer to your API calls, and then those API calls will automatically be logged in what we call as Cloud Trace, and you'll be able to see
But
that.
out of the box, you don't have an easy way to do a comparison, latency comparison between different models.
Again, that will come as soon as you integrate. Sorry.
So no, we have done that integration with Elastic Observability. So if you're using Elastic Observability, you can pretty much do it on Gemini or any model or Vertex AI platform.
And it will give a dashboard of comparison.
Exactly. Sure. We are enhancing though right now as you speak, but that's the intention. We have some features baked into this observability platform, and we are also working on additional things like how can we log the prompt? Because logging prompt is usually not encouraged, but at the same time, as part of your testing, you may want to log the prompt and response space to validate. So that is a feature which we are working on as we speak.
And in this, which of these metrics will actually showcase hallucinations?
So we have custom metrics, right? So let me try to pull up the bundle. So specifically we call it groundedness. So there's different types of groundedness at different. So let's say if you're trying to do summarization, there's a summarization groundedness. If you're trying to do retrieval or exact match based groundedness, so you can write that. And again, we have written our own custom template, but if you think that there's some kind of a definition that you want to bring to your groundedness and allow it to influence some sort of creativity, and you still want to give it, a higher grounded score, you can do that as well with a custom metric. Yeah. Sorry, go ahead.
For the e-commerce demo, what's the data set that you're using for the Elasticsearch?
So we use different data sets. Like I said, we get crawled as part of one data set. For the order details, we use BigQuery. BigQuery, we wrote it to Elastic.
And that BigQuery data is from crawling
It's
websites?
just dummy data set.
Okay,
Public data set.
gotcha. All right. I'm just curious.
Yeah. So the next slide, if so that GitHub has all the details.
Oh,
I think when
nice.
Philip sends that,
Okay.
has steps on how to sign up for Elastic Free account, Google Cloud Free account. You can pretty much try to change it. And like Abhi mentioned, the demo only focused on retrieving and sending it the response. But now you can add the evaluation as part of your pipeline to make sure the responses are always accurate.
Yeah.
And also make sure which model is responding, the auto SYX
Yeah.
pairwise evaluation. And also help identify which model is accurate for my use case and go for production.
Yeah, and then one more question. You mentioned the function tool test that you have. I'm working on a research project where we want to take 10,000 APIs and then create 100,000 Q&A pairs of high quality multi-turn agent like user examples that might actually happen in real life. Is this something that I could use to be able to check the quality of the tools in terms of not only if they're making the query, but if the output is consistent, if it's giving us accurate output, things like that?
Absolutely. This is kind of the exact use case it's built for. In fact, we are launching some more new features around agent evaluation as well. So in case you want to take it one step further than just one single function call, if you want to ensure that there's a specific
Function
workflow.
calls, right? Like, book me a ticket somewhere where it's sunny. So first it needs to find the weather, then it needs to find the city, then book the ticket.
Exactly. So we are launching agent, we are adding it to this basically, more on agentic evaluation.
Okay, yeah. Love to talk to you in more
Yeah,
detail about
for
that.
sure. Yeah.
Is the context window evaluators impact the score substantially?
What do you mean? Like,
Because if the question is complex, the context window is larger. Evaluations of part is subject to the context size to submit to it.
correct. But we use,
Do you have to control variable size of context, or you can do whatever that your assumption is?
I mean, we use Gemini as an auto-rater model, Gemini 1.5 Pro, which is our flagship model. And Gemini 1.5 Pro has a 2 million. So unless your context is,
I think the context size may not influence or impact the score, but the quality of the prompt may impact.
but I would also say, I guess that would be a valid thing to think about if you're doing like batch evaluation in a single API call, where you're evaluating, let's say, 200 queries with 200 docs. Yeah, that would ideally, because it kind of needs to find the exact document within its context window and stuff. Yeah, but yeah, if you're using it for one, which is what we do, I don't think it should matter much. Yeah. Awesome. Any other questions?
Yeah, I have a question about embeddings. So we have a customer that we're working with on the multimodal thing, and they had a concern, what if you will change the embedding?
Yeah.
So today you are doing one thing and we using 4 million images for generating the embeddings.
Yeah.
And tomorrow Google will say, you know what, we actually would like to switch to something else. It'll be big.
Yeah, I understand. In fact, that's kind of the reason why, if you take a look at, if I just go all the way back, you can see that our very first model, 001, is still there. And again, we version all our models. So you can keep that, so that you can reuse. Yeah, of course. Awesome. Yeah, sorry.
I had this conversation with the Google before. We noticed the Gemini, the foundation model do move quite often.
Foundational model, what? Sorry?
They change.
Okay.
So if I build some metadata on top of it, I don't like the language model move too much because it impact my statistical model
Yeah.
of my vectors.
Yeah.
His solution tell me to use Llama.
Okay. I mean, I
You
would.
know what I'm saying? Because usually it's go to update your internet data, it just go to increase the stuff. But I mentioned that there we slightly different.
Okay.
And the response will be different. So my vector database that I clean up for one particular versions.
Yeah.
We have corner case that will not cover with the new one.
Correct. No, I would.
You know.
I would say I'm like very sure we don't change an existing endpoint. So let's say if we deployed a model to Gemini 1.5 Pro 001 and it's a GA candidate, we don't go to update that model. In case of any updates, like you might have seen a new model on LMSys now, right? That's number one on the charts. So we would probably release it at Gemini 1.5 Pro 002, but we will never deploy to the old endpoint.
Is it guarantee available forever?
Sorry. Yeah, I mean, not forever, but if we set a deprecation date, we will give you 1 year worth of heads up, basically.
Yeah, that's how Google do it.
Yeah. So our oldest model, which is Palm 2 or Text Bison, is being deprecated in December. But yeah,
But all the meta database you work on is going to be trash.
well, not necessarily
From
because,
scratch again, you test it.
but you ideally also want to update to the latest models so that you get better instruction following and better answer quality.
You think how human.
Yeah. I would say the best way to do this is to have some sort of a unit testing pipeline, which kind of does an A/B test for you. Yeah. Awesome.